let's plot a velocity time graph for this accelerated motion. Time 0 second, velocity 0 meters per second. Time 1 second, 10 meters per second. 2 seconds, 20 meters per second. 3 seconds, 30 meters per second. 4 seconds, 40 meters per second. This gives us a straight line graph with a non-zero gradient. In other words, it's not flat, there is a slope. What does the gradient of a velocity time graph mean? Rise over run is delta v over delta t, which is acceleration. What does the area underneath the velocity time graph mean? In this case, we have a triangle, so it's half base times height, which is half maximum velocity, which in this case equals average velocity, multiplied by time, in other words, displacement. Let's calculate the area beneath the graph for these two intervals. First, 0 to 4 seconds. This gives us just a triangle. So area equals half base times height. The area, which means displacement, is equal to half delta v times delta t. In other words, half v final minus v initial times t final minus t initial. V final 40, v initial 0, t final 4, t initial 0. So we have half 40 minus 0, 40, multiplied by 4 minus 0, 4. Half of 40 is 20. 20 times 4 is 80. Notice that the units cancel to meters. We have meters per second times seconds. That gives us meters as the answer. And that is how far the stone fell during these 4 seconds. Final position 80 meters, initial position 0 meters, so the displacement, delta x, is 80 meters for this interval 0 to 4 seconds. Now let's calculate the area beneath the graph from time 1 to time 4 seconds. Notice that now we don't just have a simple triangle. We have a rectangle and a triangle. So we need to break our calculation up into 2 steps. We need to calculate length times breadth, the area of the rectangle, and then add that to half base times height, the area of the triangle. That's going to give us the displacement of the stone during this interval. Length times breadth is v initial times delta t. And then we add half delta v, the height of the triangle, times delta t, the base of the triangle. So first of all, let's get the area of the rectangle. Length times breadth. 10 meters per second times 4 minus 1 seconds. So that gives us the area of the rectangle, 10 times 3, 30. The unit is meters. Meters per second times seconds gives us meters. So we have 10 meters per second times 3 seconds gives us 30 meters. 30 meters is the area of just the rectangle underneath this graph. In other words, that's how far the stone would have gone if it had traveled at the initial velocity all the time. If it had traveled for 3 seconds at 10 meters per second, the initial velocity. But it doesn't just travel at the initial velocity. Its velocity gets faster. So now we have to see what is the contribution of the acceleration to how far it goes. And that's what the triangle tells us. So now we have to also calculate the area of the triangle, half base times height. So we have half. Now to calculate the height, we calculate the change in velocity. Final velocity, 40 minus initial velocity 10 meters per second. And then we multiply that by the base. The base is the duration of time. Final time 4 seconds minus initial time 1 second. 4 minus 1 second, 3 seconds. So the area of the triangle is half 40 minus 10 meters per second multiplied by 4 minus 1 seconds. So the area of the triangle is half 30 meters per second multiplied by 3 seconds. Half of 30 is 15. 15 times 3 is 45. The unit is meters because we've got meters per second times seconds. The seconds cancel. We're left with meters. So we see that the area underneath just the triangle is 45 meters. That means that due to the acceleration, it travels 45 meters. If it had only accelerated, it would have traveled 45 meters. But now it did both of those things. It was traveling at its initial velocity, and then on top of that, it accelerated. So its displacement is the sum of the two influences. distances. So it is displaced 30 meters plus 45 meters, 75 meters. So the total area underneath this graph for this interval 1 to 4 seconds is 75 meters. 30 meters for the rectangle, 45 meters for the triangle, 75 meters for the entire area. And that is indeed how far the stone traveled for this interval, because at the end of the interval it was 80 meters from the start, and at the beginning of the interval it was 5 meters from the start. So in between those 2 points it traveled 80 minus 5, 75 meters. That was its displacement.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!